always talk about. So who's reading? So thank you so much, Sissy, for that wonderful prayer. So I would like to take the attendance of the class. So I will read the name, and if you're present, you say you're present. If someone is absent, you still tell me. So we have Nachi Desi, then Napka Joan, then Ismenta Kodra, then Napka Joan, then Ismenta Kodra. Nice. Number contingent. So okay, today 2 people are absent and 3 people are present. Let's look back. I'm trying to find out what's happening. So today, I'm going to look at something interesting. I'm going to look at reflection of light on light surfaces. And today's objectives, we have these 4 basic objectives that we should know before you leave this lesson. Before we finish this lesson, you should be able to answer these 4 questions I'm going to give. So the first question will be, or the first objective will be defining reflection of light. Then also listing the 2 types of reflection. Then also stating the laws of reflection of light. Then the last thing will be describing the nature of images from the plane mirrors altogether. So, who has ever, okay, I will ask, how many of you have plane mirrors at home? How many of you have plane mirrors at home? I see. Yeah, I have a mirror. You have a mirror, you don't have a plane mirror. It's okay, you get to understand what a plane mirror is. So, for those that have mirrors and plane mirrors, because all of them are the same things, have you ever tried looking at yourself in the mirror? Yes. And what do you see? But I dislike class answers in my lesson. So please raise up your hand and give me your answer together. So sister has told us that for her, when she tried looking at herself in the mirror, she saw someone like her, exactly like her in the mirror, I would say. So what helps you see that, or what do you think causes us to be able to see ourselves in the mirror? You see your exact self in the mirror is what we call the reflection altogether. Because what you see in the mirror is a reflection, because it's the exact you, though not the real you altogether. So, in simple terms, how would you define reflection? How would you define reflection? Yes, sister.
Reflection of light would be like, okay, I can explain it in a way that maybe you look into a mirror and then you're able to see your very self, or like your real object. It could be like there is something of bouncing back of the light rays, like when you focus your sight into the mirror, light is bounced off back and then you're able to see the full image.
Okay, let us finish it, sister. So, as sister has tried to explain, her in her own thinking, she thinks reflection kinda maybe involve some bouncing, some light rays, because all of us, or the entire space is surrounded by in the definition, I would say reflection is the bouncing back of light rays, yeah, from a smooth reflecting or from a smooth surface. It's actually just a bouncing back of light rays on hitting a smooth reflecting surface. So, me asking you whether you've ever seen a plain mirror or you've ever looked at yourself in a mirror tells you that this plain mirror is smooth.
Yes.
As you can see this mirror, I'll give all of you to try touching it. So Bridget, touch that mirror. How do you feel?
I can't see myself.
I've said touch the mirror. How do you feel?
It is smooth.
Yes, give the quadra. Yes, Cisse.
The surface is smooth, and then the surface is kind of this one. Not so smooth, but a little bit rough.
Okay, thank you so very much, all of you. So, this mirror is very smooth. That's why when someone tries to look through this mirror, you'll be able to see your very own self. You'll be able to see your image out again. So, the process by which you're able to see your very own image is the process we call reflection. So let us read that definition, all of us.
Reflection is a process by which light energy bounces off from a reflecting surface.
Very good, thank you very much. So, after us knowing the definition of reflection, we know that since I've told you this surface of the mirror, or you've discovered yourselves that this surface of the mirror is smooth, not so? So it indicates to you that there could be some surfaces that are not smooth and other surfaces that are rough. Are we together? So you'll find that on some rough surfaces you won't be able to see yourself clearly, or on others you totally not see yourself. Are we together? So the nature of reflection, or the type of reflection we have different types of reflection, and these types of reflection depend on how light energy, because you say reflection is a process by which light energy bounces off from a reflecting surface. So the way this light bounces off from a reflecting surface will be determined by the nature of the surface on which it is striking out together. So this leads us to our next subheading, which is the types of reflection. So, for this, I will not make it complete and new, but for the types of reflection, we have two. I'll explain to you one, and we'll then try to pick about the other and tell you what it is out here. So, the first type of reflection is regular reflection out here. And this reflection is the kind of reflection that you can see on a plain mirror. Are we together? The fact that you're able to look into this mirror and you see yourself, it tells you that the light rays that are coming from you and striking this mirror are striking it at different angles. Are we together? So when they strike it at different angles, they are also reflected back towards you, still at the same angle. Are we together? So it's a perfect kind of reflection. They come parallel and they also go parallel. Because we know that light travels in a straight line, not so? Yes. So, a clear definition of regular reflection would be, it is a type of reflection attained when a parallel beam of light incident on a smooth reflecting surface is reflected still as a parallel beam out together. For example, the image that you see here, are we all seeing this image? Yes? So in this image, we see, what are you seeing in this image, first of all? So these rays that are coming, as predators told us, they are coming in a straight line, and they are striking a certain surface. Are we together? And when striking this particular surface, your findings. So, I've given you some time. I think we trying to come up with some solution. So, what do you think the other is? Any volunteer among you to tell me? Yes, Kodra.
We suggested that the normal ray, the reflected ray, and the incident ray, they all meet at the same point.
Wow! I teach brilliant students. That's very good. That's very good. For example, to kinda try to clarify the answers, how we try to come up with that. When we try to take a clear look at this first ray, let us all focus on this first ray together. So we have this first ray coming, it strikes the surface out again. And on striking the surface, immediately it reflects out together. So it reflects this first reflected ray. No, so? So it means this incident ray and this reflected ray, all of them are at a certain point. Are we seeing that particular point where the end eye of the incident coincides with the end point of the reflected ray out together? So that's good. Yes, very good. So those are two laws. And to polish them, we would say that the first law states that the incident ray, if we look at this image in this work, the incident ray, which is this, hope you're seeing the word, this incident ray, this reflected ray, and the normal, this is our normal. Sorry, I forgot to tell you about the normal. So that normal is that perpendicular line, out together, that perpendicular line, and it's in most cases imaginary, out together. So that perpendicular line that you draw and strikes your smooth reflecting surface, it's what we call the normal. It makes an angle of 90 degrees with your smooth reflecting surface, out together. So we have the incident ray, reflected ray, and the normal, and they are telling us at the point of incidence all lie in the same plane, out together. So hope you understood that first law. And the second law is telling us that the angle of incidence is always equal to the angle of reflection. Remember, these rays, as you've seen, let me take you back to the regular reflection. These rays are coming, but they are at a particular angle. So this image, we can say that this image is laterally inverted. Are we together? So it's one of the characteristics of images formed in plane mirrors. The image is laterally inverted. Then there is also some other thing. When you try to look into this mirror, you can maybe hold your pen. Bridget, hold this mirror. When you look into the mirror and see the image of that pen, how is it? Wow, it is the same as the. What I know, the image is also standing, not so? And this lid is still on top, not so? And this pointed part is down. So we can say that the other characteristic of images formed in plane mirrors is that the image is upright. So I'm giving you a task. We all have mirrors at home, or plane mirrors at home. Go back at home, look at yourself in the mirror, then try to write down the other characteristics of images formed in plane mirrors. Are we together? Okay. So this marks the end of our lesson. You've been very good students. And to those that have not come today, I know the few of you that have managed to come today, you'll be able to clearly explain to them what you've learned. Not so? So thank you very much. We shall meet tomorrow. Who knows what this surface is? Is it rough or smooth? Yes, yes. So this surface of ours is smooth. That's why these rays that are originally parallel strike this surface and still are reflected as parallel. So this clarifies our definition, don't so? And our definition was, what is regular reflection? We all read.
This is the type of reflection attained when a parallel beam of light incident on a small reflected surface is reflected as a parallel.
Yeah. So I told you before I started the subheading of types of reflection, I told you I'm going to give you one type of reflection and you're going to tell me what do you think the other type of reflection is. So if this is regular reflection, what do you think the second type of reflection is? Yes, Cecil?
I think the second type of reflection is one that takes place on rough surfaces.
Yeah, let's start for Cecil. Any other idea? What do you think the second type of reflection is all about? You can maybe give me its name, or you can tell me one of the things that differentiate it from this first type of reflection. Yes, Bridget?
I think since that one was a smooth surface and you're able to see yourself, for a rough surface, maybe you can't see yourself.
Yeah. Let's like for Bridget. Another idea. Let us think. Let us try to share. You can share among yourselves and try to come up with something. What do you think the other type of reflection is? Please feel free. This is the competency-based yes program.
In that type of reflection, the reflected rays, like the rays were reflected in the same direction. So it means that the other one, it might be that like the reflected rays are in different directions.
Wow.
Since the surface is
Let's start the program. So, okay, I will take your opinions and they're all right. So, our next type of reflection, though you didn't try to give me the name, but it is for most physics concepts. If one thing is, for example, regular, then the other will be the opposite of regular. Are we together?
Yes.
So, if this is regular, then the other will be irregular reflection. So, we come to this. So our other type, or the second type of reflection, is the irregular reflection. Are we together? And all that you said is true about irregular reflection. Are we together? Kodra has told us in irregular the directions in which the reflected. Kodra has told us in irregular the directions in which the these reflected light rays go through. These ones are together. Their direction is not perfectly parallel as we've seen in the regular. Out together, these ones are parallel, perfect. But these ones are reflected in different directions. And still, as Cisse told us, she said in regular reflection, the surface was smooth. Are we together? But for this case, for her, she thinks the surface is rough, and it's correct because in this other type of reflection, you see that this surface has some kind of bumps. Are we together? Though these bumps cannot be seen using your physical eyes. Are we together? But it has some bumps. It's not smooth as we've seen surface, and you also see the difference between the surface of this other one. Yes, Bridget.
If that surface is smooth, can it, so it is rough, can it be a road?
Yeah, it's possible. It can be, or it can also be a mirror itself, but not as you touched earlier. This surface of this mirror, it was smooth, not so. But there are some mirrors that when you touch it, you feel like it's not that perfect smoothness altogether. So that's why I've told you these rough surfaces, you may not be able to view them physically or with your naked eyes altogether. Sometimes you use some instruments which are called microscopes to view this roughness of these surfaces altogether. So that is it. Hope I've answered your question.
Yes.
So our clear definition for irregular reflection would be, it is a type of reflection attained when a parallel beam of light, this parallel beam of light, this one altogether, when this parallel beam of light is incident on this rough surface and it's reflected back in different directions altogether. So that would be our irregular reflection. Hope we are clear there. Yeah. So after us seeing what is reflection, the types of reflection, known their definition, we've known how they look, how maybe we can be able to draw their geometric diagrams altogether. So we are now going to our next thing called or titled the laws of reflection altogether. Since we are studying physics, we know that physics is governed by laws and rules altogether. So still this topic of ours, reflection of light, it's also governed by some two laws altogether. But I remember these two laws, you might have studied them in your primary altogether in science. So can we try to memorize? Can we try to remember what are the laws here there? Yeah. So after us seeing what is reflection, the types of reflection, known their definition, we've known how they look, how maybe we can be able to draw their geometric diagrams altogether. So we are now going to our next thing called or titled the laws of reflection altogether. Since we are studying physics, we know that physics is governed by laws and rules altogether. So still this topic of ours, reflection of light, it's also governed by some two laws altogether. But I remember these two laws, you might have studied them in your primary altogether in science. So can we try to memorize? Can we try to remember what are the laws of reflection? Yes, Cecil.
While we were looking at radial reflection, we talked of the incident rays being incident on the surface at the same angle as the angle that they live with as they reflected off. So that could be one of the laws that maybe the angle of incidence of the rays must be equal to the angle at which they reflect off the surface.
Yes, that's a very good answer. Let's clap for her. But Kodra is very silent. I don't know why. Kodra, try to give us something. She's hungry. Don't worry. When we finish this lesson, you follow me to the staff room. Yes. So try to give us something. What do you think the other law is? You can discuss among yourselves. Share some ideas and tell me. By virtue, I mean it cannot be touched altogether. So we are going to look at those different characteristics. And with that, I'm going to give this mirror to Bridget. Hold it for me like that. Hold it for me like that, and I'll give this to Cisse to hold for me like that. Or maybe that's me. Let Kudra hold this. So, are we seeing some? Cisse, are you seeing something in the mirror? What are you seeing? Yes. Yes. Wow. So, as you're still looking at this in this mirror, how can you describe the appearance of letter J? How is it looking like? Okay, so she's saying letter J is like this. Then how is letter B looking like?
Letter B is like this.
Yes, she's also saying letter B is looking like this. So any other feature you're seeing on how those letters are? Yeah, that's true. So she's saying the letters are like this, but actually the others, oh, Bridget, how are you seeing those letters from here? You can write them here. Okay. So with that, I will tell you how we can characterize this. Are we together? So initially, the letters written are like this: J, B, C. Are we together? But then the letters you're seeing are like this, though they both wrote in different senses, but the letters you're seeing are now like this. We know that our journey. So hope we've understood that. So this is our incident ray, this is our normal, this is our reflected ray, and this angle I is the angle of incidence. Are we together? And this angle R is the angle of reflection. Yeah. Are we tired? You're not tired? It's okay, let us first stand up. Let us all stand up. Let us stand up, let us stand up. You're still young, you're in senior one, you still have some more years to go. Yes, stretch a bit, stretch a bit, stretch a bit. So, okay, I think that's enough. You can sit down and continue. Don't worry, we're about to change. So, our next interesting subheading we are going to look at is images found on plane mirrors. I remember as we were starting this lesson, Bridget told us for her she knows a mirror. She does not know a plane mirror, and so, and the others you say do know plane mirrors, and that is okay. But Bridget, my dear student, a mirror is the same as a plane mirror. Are we together? Though for this at this stage you're on, I can't go into deep into the other types of mirrors. That's because we have different types of mirrors. Are we together? But what you should know at this point is that a plane mirror is also a mirror. Are we together? So the mirror you use to look at yourself at home is called a plane mirror. Are we together? So we are going to look at now the images that are found on plane mirrors. How do those images look like? Are we together? Are they real? Are they virtual? By real I mean, can you touch it? Are we together? By virtual I mean, it cannot be touched. Are we together? So we are going to look at those different characteristics. And with that, I'm going to give this mirror to Bridget. Hold it for me like that. Hold it for me like that. And I'll give this to Cisse to Or maybe that's green. Let's Kodra hold this. So are we seeing some? Sisi, are you seeing something in the mirror? What are you seeing?
I can see letter J,
Yes.
letter B.
Yes.
And C.
Wow. So still as you're still looking at this in this mirror, how can you describe the appearance of letter J? How is it looking like?
Letter J is